show IP interface brief is going to be a show command that you go to more often than you could ever imagine. Now, why is that? Well, it gives us a brief snapshot as to the different layers of the OSI model. And you might be thinking, wait. Are you talking about the application layer, the presentation layer, the session layer, the transport layer, the network layer, the data link layer, and the physical layer? Yeah, that's the OSI model I'm talking about. That's 7-layer OSI model. But this doesn't tell me about all 7 layers. What does it tell me about? Well, it's going to tell me about layer 1, 2, and 3 of the OSI model. So when I'm analyzing the output of show IP interface brief here, I can see the interface names. So that's really nice that the interfaces are labeled by their names. We can see we have our embedded services engine on this router, gig 000102, and a serial interface. But I want to focus more over here, for example, with layer 3 of the OSI model. That's right, layer 3. It doesn't tell me a whole lot about layer 3, but it does tell me I have a layer 3 IP address, and the layer 3 IP address happens to be 10.1.1.1 and 10.1.12.1. So I know I have layer 3, or the possibility for layer 3 communication, because I have an IP address on the interface. But in order to have layer 3 communication, I need to be up at layer 1 and layer 2. So let's focus over here on the status column. The status column is all about layer 1 of the OSI model. So layer 1 of the OSI model is all about physical connectivity. It's all about the electrical, the mechanical, the procedural that is going to happen in order for us to successfully send bits across the wire between our devices. So right now, if you notice, we have R1 connected up to DSW1 out gigabit 0/0. So if we focus on gigabit 0/0 here, we come all the way across, we can see that our status is up for layer 1. So we're up at layer 1 right now. What does that mean? It means that the router itself can physically communicate with DSW1. And if you focus on gig 01, come all the way across, it also says up. So we can successfully communicate at layer 1, the OSI model, with R2 out gig 01. Which would imply that in return, from a physical layer standpoint, that DSW1 can talk to R1 and R2 can talk to R1. It's really difficult to be up at the physical layer on one side and down at the physical layer on the other side, because it's a bidirectional communication that has to happen. So we would be up on this side and up on that side. Let's focus over here on protocol. Protocol is all about layer 2 of the OSI model. And what I want you to see about the protocol column is that we also have the descriptions of up and down. Up is good, down's bad. So what are we talking about here? We're talking about the ability to encapsulate packets. Pardon me. We're talking about the ability to encapsulate frames. Take our Ethernet frames in this particular case, our gigabit Ethernet 0/0 interface, creating those Ethernet frames, or gigabit Ethernet 0/1 interface, creating those Ethernet frames. Are we able to successfully create those frames and communicate over to the other device on the other side? So layer 2 of the OSI model, the data link layer. Can I successfully speak to the other side? Are we using the similar protocols? In this case, Ethernet. Down at the serial link would be using things like frame relay or PPP or HDLC as an example. So we'd have to be speaking the same language, using the same encapsulation methods on both sides of the link in order for it to be up. So whenever you analyze the output here of status and protocol, up means physically we're great. And from a data link layer perspective, we can talk to each other across that physical link. So what are some of the other options we might run into? Well, what if we saw up, down? So let's say we were up over here, but over here, we were actually down. Well, in that case, it means we have successful physical communication. But from a data link layer standpoint, layer 2, what is happening is that we have an encapsulation mismatch. Maybe one side is using one layer 2 encapsulation method and the other side using something slightly different, or maybe completely different. For example, on a serial interface, if I have one side of the connection configured with HDLC and the other side configured with PPP, those are two completely different encapsulation methods. So as a result of that, we would be up at layer 1 because we have physical connectivity, but we would be down at layer 2 because we can't speak the same language. We don't understand each other. So that would be up, down. What about down, down? What would down, down mean? Well, down, down means we have a physical layer problem. That's right. Physical layer problem. We're down at layer 1 because we can't talk at all across the link. We can't even send bits out of the interface or receive bits on that interface. That's what down, down would mean. Now, notice it doesn't mean we have a layer 2 problem. Even though we're down at layer 2 in that case, the problem's at layer 1. In order for layer 2 to be up, layer 1 has to be up. So you can be down, down. That represents a layer 1 problem. You can be up, down. That represents a layer 2 problem. You can be up, up. That means everything's fine. But could you be down, up? No, you can't. You can't be down, up. Because down would imply you're having a problem at layer 1, can't even communicate across the physical wire. And up would mean that, oh yeah, I can successfully encapsulate frames and send them to you. But wait, I can't talk across the wire because there's something wrong with the wire. That's why it's down. So you'd never see down, up. That is not possible. So up, down, 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 all possible. And last but not least, our administratively down option. Administratively down means the shutdown command has been executed on that interface. So let's go to the output of show run interface serial, or we'll go to gigabit Ethernet. Show run interface gigabit Ethernet 0/2 shutdown. So this command here is what causes this to be administratively down. So what it means is that it's disabled. It's disabled from an administrator standpoint. So if you want to enable that interface so it could go up, up, you would have to type in the no shutdown command at interface level in order to do that. So very important output, show IP interface brief. You can verify layer 1 with the status column, layer 2 with the protocol column, and then layer 3 with the IP address column.